So hello, I'm Quentin Courte from UC Louvain, and I will present you my paper, SPST and SPDT 60 GHz traveling wave switches in 22 FDX technology. So on the first part, I will explain the design philosophy of a simple traveling wave switch. So basically, you have the inductance and the two transistors, and when the transistors are off, it acts like a capacitance, and the conjunction of the capacitance with the inductance will create a 50 ohm line that will be able to transmit the RF signal without losses. And then if we turn the transistor on, basically we have a short towards the ground, and it will simply prevent the signal from going from port 1 to port 2. So the design philosophy is the following. If we can sweep the value of the inductance here, and for a given inductance, I will have to select a given capacitance of the transistor to be able to get a 50 ohm line. And once this sets the dimensions of the transistors, and when it is done, basically we got the R-on, the on resistance of the transistor, which will dictate the isolation of the switch. And also, yes, the value of the inductance also has a small effect on the isolation. And an important factor also to consider is the impact of the R-on C-off of the device. So basically, if the R-on C-off is, let's say, 100 femtoseconds, I will have a given isolation, but if the R-on C-off is twice that value, basically I will have to compensate the capacitance, the parasitic capacitance, by reducing the dimensions of the FETs, which will reduce the isolation by 10 dB, for instance. So the effect of the parasitic capacitance is absolutely huge. And then, so this is the SPST. The measurements are here. So from we are able to achieve insertion losses below 1 dB up to, from DC up to 78 gigahertz. And at 60 gigahertz, which is the target frequency, we have 0.72 dB and isolation of 28.4 dB. And then there is the quarter wavelength impedance transformer, and in conjunction with the SPST, we can build with this the SPDT. And the performances of the SPDT are 1.64 dB of insertion losses at 60 gigahertz and 32 dB of isolation at the same frequency.